My name is Readington, and I am an application engineer here at Avid Product Development. So vapor smoothing is the process of taking a chemical solvent and basically melting the surface of the part. So what that's doing is taking material from the top of the mountains and filling in the bottom of the valleys. When a customer orders a vapor smooth part from Avid, they can expect to receive a part that's very similar to a non-vapor smooth part, but just has a much smoother surface finish. There's a variety of reasons you might want to vapor smooth your part here at Avid. One of the first ones is basically how the part interacts with fabrics and textures around it. The microtexture of the unvapor smooth part can be kind of abrasive, almost like a very fine grit sandpaper. When that interacts with a fabric or like a microfiber, it can tend to attract lint and dust from that fabric and kind of make the part look dingy after a while. If your part's going to be used in any sort of environment where it can come into contact with water or fluids or oil, the vapor smoothing process really makes it easier to clean the part afterwards. All of the vapor smooth parts here at Avid are certified for skin contact, so some of the oils from your skin can tend to accumulate in the part, and the vapor smoothing process allows you to take regular soap and water and kind of scrub your part and get all those oils off of the surface very easily. Some of the best examples that we have of vapor smoothing here at Avid are in the medical and industrial spaces. The medical is great because it allows the parts to be easily cleaned and kept sanitized, and vapor smoothing allows our industrial applications to be kept cleaner and looking nicer for longer. The first thing we're going to do when we prepare your part for vapor smoothing is we're going to choose between one of 3 or 4 methods to hang that part inside of the chamber. The first thing that we can do is to just place your part directly on the grate. One of the downsides of that is you're going to see artifacts from the grate along the bottom of your part, potentially even a small checkered pattern if we use a very small grate. The next options are a paper clip or some sort of metal wire or this Teflon cable. These 2 methods are great if you're trying to avoid the metal mesh marks on one side of your part. And then the final method that we can use are these small metal clips. These metal clips are great for holding on to flat geometry, but the downside is these have the largest surface area, so they are going to leave the largest artifact after the vapor smoothing process. Another thing we can do is add sacrificial geometry that we can then hang the part from, either a small hole or a small tab, and use the metal clip. And then that part is cut away after the vapor smoothing process. And if you've got any questions on how you might want to hang your part, feel free to reach out to Avid and we'd love to help you. Another thing to consider when you're designing your part for vapor smoothing is using a uniform wall thickness throughout your part. Having non-uniform wall thickness on your part can change the thermal mass within a certain area of the part. Having non-uniform thermal mass can leave some areas of the part more smooth and other parts unsmoothed. Having uniform wall thickness creates a uniform thermal mass throughout your entire part, and that leads to a more uniform vapor smoothing process. One of the final things you want to consider when designing your part for vapor smoothing is avoiding large cavities or deep bores. These are less than ideal geometry because the small opening, but large surface area behind that opening does not allow enough of the solvent to fully attack the surface and create a uniformly smooth part. Some of the common misconceptions around vapor smoothing include the material turning into something that it's not. This is still a PA12 nylon or TPU or PA11 part. It just has a much smoother surface finish. At the end of the day, this is still the same base material. Another common misconception about the vapor smoothing process is that it changes the dimensions of the part. Since only a solvent is being used, no material is being added or removed from your part during the process, so your nominal dimensions stay very close to the CAD model. Here at Avid, we're often asked whether or not a customer should vapor smooth their part. One of the biggest reasons we might suggest it is if that part is going to be directly customer facing or something that the customer is directly interacting with. Any part that the consumer directly interacts with tends to absorb finger oils or moisture, and the vapor smoothing process makes it much easier to clean and keep sanitized. One reason a customer might not opt for vapor smoothing is they're very early in their design process. If they know that there's going to be multiple revisions of a part coming very soon, the vapor smoothing process just might not be necessary. It does add time to the printed part process, and rapid prototyping may be more important at this time. When we're discussing pricing with a customer on the vapor smoothing, there's kind of 2 things we can look at. We're happy to sell you the full chamber of parts, and we'll put as many parts in there as we can. Another thing we can do is hold your parts and hold other customer parts and vapor smooth those as a batch. The great thing about vapor smoothing your parts with other people's parts is that we can share the cost of that batch across multiple customers and save everybody some money. Vapor smoothing is beneficial for our customers because it allows them to prototype closer to what their final injection molded part will look like. A vapor smooth part can be almost indistinguishable from an injection molded part, allowing them to prototype with something very close to their final product. We hope you found this video informative, and if you've got any questions, please don't hesitate to reach out.